parametric curves are given by different functions where x will be a function of t and y will be a function of t. So what we have here is x depends on some variable t, which is usually time, and y depends on some variable of t, which is also in time. So both the x and the y coordinate for some specific curve depend on t. So what we're going to do is we're going to take a look at so this is a parametric curve defined by this, and our parameter t is given some interval. Okay, so we're going from negative infinity to infinity. So just to kind of give you an idea of what a parametric curve is in case you haven't seen them before, what we can think of this as is, let's say we've got t. It's not the best line, let's redraw that. Then we have x as a function of t, and also y as a function of t. So let's say t, for example, is 0. Well, if t is 0, then x of 0, okay, that's what this guy is right here. Let's do this in yellow. So x of 0 is going to be 0 to the 4th, which means x of 0 will be 0. And then, of course, we'll take a look at y of 0, which would be 0 squared. So y of 0 is also 0. So this leads us to, let's just go like this. Let me erase this here so I have a little bit more space. So this will be the point xy. Okay, and so the point 0, 0 is on our graph when t is 0. So if we take a look at the graph of our curve, this guy right here represents, let's say, time. Let's say t is time, time 0. Okay, that's where you can think about this as maybe like a bug or something like that walking along some curve, okay? And at some certain time at t equals 0, it's right here at the origin. Now I'm going to pick some different t values here. So let's say we let t equal 1. Well, then this first guy right here is x at 1, which we know that that's going to be 1 to the 4th, which is 1. And then, of course, when t is 1, y is equal to 1 squared, which is also 1. So the point 1, 1, that's when t is equal to, not 0, t is equal to 1. That's on the curve. So let's plot that out. So 1 over 1 up. So this guy was when t is 0. This guy's when t is 1. Let's try maybe 2 and 3, and then we'll stop with the positives and we'll go in the negative direction. So when t is 2, we get 2 to the 4th, okay, which is 16. Okay, so that got big really quick. And then here we've got 2 squared, which is 4. So our x value is 16. Our y value is 4. That's when t is equal to 2. So we've got to go out to 16. Let's just say 16 is out here. And then 4 up there. So this right here is when t is equal to 2. And of course we can do when t equals 3. So when t is 3, we've got 3 to the 4th, which is 81. And over here, we've got 4 squared, which is 16. So the point 81, whoops, why did I say 4 squared? 3 squared is what I meant. Is 9. Okay, just like that. So we'll plot this point. So we have to go 81 out. So let's just put that way out here, and then 9 up. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're assuming that this is out at 81, and so this would be up somewhere up here. So this is, if you're thinking about a bug, at time 0 it's here, then at time 1 it's here, at time 2, at time 3. So its travel path looks like it's headed in that direction. Now, of course, t isn't just positive numbers, t also goes towards the negative. So we plug in -1, and when we do that, we get 1 and 1 out. Okay, again, we plug in into those formulas. So this is also a point, which is also right here. Okay, when t is -2, we'll get out the points. These guys right here, so 16. And for x, we'll get out 4, okay, which again is this guy right here. So you see that we're traveling this path again one more time. And so what I want you to notice is that negative times lead to things out here. So when we think of a parametric curve, we think of a path traveled. So what's happening is when t is negative, our bug is way out here and it's traveling in this direction, just like this, until it gets to t equals 0, and then it hits here, and then it goes back along the line in this direction, like that. So we've got movement this way when t is negative, it hits 0, and then when t is positive, we have movement back out this way along this line. So we really go in both directions along this line. We slide in, and then we slide back out. And that's our path travel. And that's how you deal with parametric curves, is they have some kind of orientation or some position where you're traveling along the curve or along the line.